Okay, so how do you fold a cordelette up so that you can carry it on your harness nicely? Well, start off with the cordelette with the sewn part there, or the knot if it's been made out of rope. Put it over your hands like that with your finger behind, and then simply wrap it round nice and neatly. And then when you get to about that amount of length on it, take it off your hand and then wind that around like so, again as neatly as possible and as tightly as you can, and then finish it off by putting that loop, the finishing loop, through the hole over there, and you can now clip it to a carabiner and carry it on your harness like that. That's called bomb style. Okay, so we're going to show you today how to use a cordelette to set up a belay anchor at the top of a trad root, particularly, which is where you would use it. So I've got the cordelette. It's a 6-meter cordelette made out of slings, and it's been wound up bomb style like this. And we undo it, and I've got 3 pieces of trad gear, 3 cams in the place here, and we'll show you how to fit these, how to fit your cordelette onto the cams, to equalize them, and then also how to connect yourself to the cordelette in a belay situation as if you were at the top of a root. First of all, I'm going to get up and put the cams. Okay, so I've clipped the cordelette. The strands are going through the 3 pieces of protection. It could be 4 pieces of protection, it doesn't matter. And the big thing here is to equalize them. You simply grab the strand of cordelette between each of the cams, pieces of protection, including these 2 at the bottom here, and you pull them down to equalize them. So, and then they are equal now in the amount of tension that they've got, but we still have to do one more thing, and that is tie them off to form a focal point. And I'm using a overhand knot here, putting all 3 strands through, and there is a cordelette. The 2 things about the way you set up a cordelette or any other belay is, number 1 is that they must all be under the same amount of tension, and they must be independent of each other. So in other words, if one of these pieces of gear comes out, the entire thing shouldn't fail or be shock loaded. And for instance, I'm pulling on here, and I'm going to release this here. This cam, we'll pretend, has come out, and nothing happens to the rest of the system. And that's the fundamental of all belays, must have that component to it, that if one piece fails, the entire thing should not fail. So I've just arrived at the top of my route. I've put in a cordelette, the 3 cam placements here. I've got the master point or the focal point, and that is what I'm going to use in order to anchor myself and the person I'm bringing up the climb. So first things first, you take a screw gate carabiner or any locking carabiner, and you tie yourself to the anchor system before shouting off belay or anything like that. And you can use some people would use a clove hitch like this. Others might use a figure-8 knot, depending on the seriousness of the situation perhaps, and whether you want to have it that you can move around more and adjust the clove hitch, for instance. Anyhow, I'm now safe because I'm on a screw gate carabiner and I'm hitched in like that. Your next thing would be you'd shout to your partner off belay, and then you take in the rope or the extra rope, and when you can feel that your climbing partner on the other end, you take your belay device, such as this one, you thread it, you clip in, and you're ready to belay the person, standing behind the belay device like that. That hand going to the climbing partner, this is your brake hand. When you set up a belay like this, just note this aspect of it. I am tied from my harness to a screw gate carabiner over here. So I'm separate from the belay system. The belay carabiner with the belay device on it is completely separate within the focal point, and if a person falls and you have to catch them, they are not being, I am not holding them on my own harness or via my own harness. They are falling completely onto the belay system, and that is a far better way of having things set up. It also means it's easier for you to escape the system if somebody has fallen and has been hurt. The other way to put in a belay to bring up a climbing partner is to use a reverso type device, and reversos are very, very useful, especially for guiding, and also very useful if you're bringing up two people at the same time. To work the reverso, you place it through like that, place a locking gate carabiner of sorts there, and then that is what this little hole is for. Hang the entire system off that, and then it means that this rope, which is going down to the climber, you can pull it through and it will lock on the reverse like that. So it's a kind of a clutch system. And it also enables you to stand in front of the belay device, and you can look down and see what's happening to your partner down below, and see how he's climbing or he or she is climbing, and just bringing it in like that. And it's a very easy system to work. If you have two people that you have to bring up a climb, you can have them climbing at the same time or simul climbing. And here we're illustrating that with one person would be on the blue rope and the other person would be tied onto the yellow rope. And as they climb, you can bring them up at different times. They'll be climbing at different speeds. And you can pull the blue rope like so, and then pull the yellow, or you can pull them at the same time like so. And then if the yellow climber is stopped, you can simply pull the blue one as the blue climber climbs. When you set up a belay system with a cordelette or any other method, one of the fundamentals of it is that you must not end up with the angles of the outer legs of the belay must not be greater than 90 degrees. As you can see here, this is a very wide angle. It's probably about 120 degrees. Now that, when you get above 90 degrees on a belay like this, you start to put undue amount of forces on the outside legs of the belay. And in actual fact, if I pulled 10 kilograms on this side here, it's putting 10 kilograms on that side and 10 kilograms on that side in this kind of situation when that is at 120 degrees. How do we fix that? It's very simple, and you want to avoid having wide angles on your belay. So one way to avoid that wide angle on your belay is simply what I've done here. I've added in a long sling, 120 centimeter sling, and I'm adding that into the system. It's extending the whole system away, and now when I make focal point, I've got a much tighter angle in the belay. And there we can see that it's about 90 degrees now, which is acceptable. So here we're going to show you how to set up a conventional belay system using a piece of rope, and some people might call this a spider's web, but it has no particular name. First of all, we've got 3 pieces of trad gear in here. We could have 4 pieces or 5 pieces, it doesn't really matter. The principle remains the same. We start off, to make this belay, start off by putting a figure 8 on the bite, and you clip it to the one side. You then bring the rope back down, and we've decided that our master point is going to be plus minus over here. You simply clip it through the next one. No knot over there. If we had a 4th piece, we could just loop it back through there, and then at the end we are going to finish it off with another figure 8 on the bite to the outer edge of the belay system. Grab them all together and equalize them, and then simply put our master point in, or focal point, and that is an overhand knot. It could be a figure 8 knot also, and that's what would belay everybody off. So the main thing when you set up a belay system like this, what you're trying to achieve is that each one of these legs needs to have equal tension on it, and each piece must be independent of the other. How do we make each side independent? If we simply went off a loop like that, it would fail if one piece came out. The whole thing would unravel itself. So what we do is we put a focal point in by putting in either a figure 8 knot or an overhand knot. And now what it means is that if, for instance, this piece of equipment came out, the entire system does not fail, and that's what you need in a belay system. One variation when you are setting up a belay system, instead of taking the rope backwards and forwards each time, there's a way that you can save some rope, especially if there's not enough rope for the entire system to be set up. And this is how you would do it. You've decided that your master point, your belay point, is going to be over here. When you take the rope back, you estimate the distance. You put in a clove hitch at this point. There you got 2 of the legs, and then you don't bring this back here, you simply scallop it across to the next point, put a clove hitch in over there, and then together or separately you can make a focal point like so. And there you have it, and you've used a little bit less rope, and you simply remember that that piece of rope there is now redundant, and you can add in, if you had 3 or 4 points in the system, is that every second one you've got to come back here in order that each piece of equipment is actually taking some of the strain. We've spoken about how to set up a system like this, and that each side must be equal, and then each leg is made to be separate from each one by putting in a knot. Another common mistake that people make is that if they don't have enough rope to make their belay, they might add in a sling into the system. Now, these points here, they appear to be under the same amount of tension. But when you set up a belay, you've got to think about what happens when it was pulled to the point of failure. That is the actual test of the system. And in actual fact, by adding the sling in, if I pulled this thing so hard that the entire system failed, long before it failed, you would find that because the sling doesn't stretch very much, but the ropes do, that all the weight was in actual fact being taken on that sling and on the cam there. and that is the one that is most likely going to fail long before the rope actually starts to take any strain. So your belay is fundamentally not very strong, not as strong as you might think it is, because all the weight actually ends up on the part that doesn't stretch. So when you set up a belay, one of the rules here is don't mix the kinds of medium that you make the belay with. If you've decided to make it with a rope, then make the entire system with the same kind of rope, if it's a dynamic rope or not. Or if you're going to make it out of slings or cordelettes, make the entire thing out of a cordelette or a sling. But don't mix up those types of components, because you get very uneven breaking strains and amount of stretch into the system. One thing when you set up a belay, whether it be with a cordelette or any other method, and in this illustration here we've got it running down back to a clove hitch, from across to a clove hitch and back here, is that we know that we say that each leg of this belay is under equal tension. Well, in actual fact, when you pull it hard, it's not under equal tension. This central component here will be taking most of the strain because it's in line with where the force is coming from, and the force is coming from there. These ones on the side take less of the strain. So what you can do sometimes, especially if you've got marginal placements, is that you might like to just add in a bit of slack into this system, to that central one, and that will help just to even up the strain on the belay system. So this one is slack now, but when we pulled it much harder, it will only start to take strain later on, and these outer ones will be taking more, and you'll get a more even spread of tension when it is under tension. The other principle of setting up a belay, and especially if you're either going to be holding a very big load, like in a mountain rescue situation where you can get very high loads in the system, or unlike the system that we've got here, you're using marginal placements, small wires, or you're using ice protection or something like that, is that you've got to start to think like an engineer thinks. And it's not about whether these things are under similar tension. You must worry about what happens when this thing fails, if it gets pulled so hard that it fails. And there are two questions that you've got to answer to yourself here. Is the belay going to unzip? So in other words, if I pulled this thing at increasing tension, would one of these cams pop out and fail, and then the next one, and then the next one? That's the zipping kind of principle. The other one is the balloon type principle, is do you want your whole belay to burst out at once altogether? Now, it's counterintuitive. We might think that we would want it to unzip itself, but in actual fact, that's the wrong method. What you want is, the principle is that you must have the balloon principle applied, so that when I pull this thing, when it eventually failed, it must all fail at once. And that's why getting the tension into the legs of the belay are so important. Why do you not want it to unzip? Well, let's use a simple illustration. Let's just use simple numbers here. Let's just say each one of these cams here was worth 10 kgs of force that it could take. So we've got 10 kgs plus another, that's 20, that's 30 kgs that this belay could theoretically hold. Now, if we pulled this to a point where it got to 10 kgs, the first one might come out at 10 kilograms, then hit the next one, which will be shock loaded, and it will fail at 10 kilograms, and then the next one will fail at another 10 kilograms. So in actual fact, although we had 30 kgs in total, because they were unzipping one at a time, this belay was only worth 10 kilograms of force. If we go to the principle of getting the belay to burst apart all at once, it means that all the components were holding at 10 kilograms, therefore the belay was worth 30 kilograms, and it is far more powerful a belay system.